So this is paragraph 6 of the reading Properties of Water. And the questions for understanding are, what are the characteristics of water, or what are the properties of water? And we've been talking about the properties for quite some time. And the properties of water, I won't take the time to write them all right here, but I will just review them with you. The properties of water are polarity. Polarity causes cohesion, which causes surface tension. Adhesion, which causes water molecules to stick to other substances. Cohesion causes water molecules to stick to themselves. Adhesion causes capillary action, which is that property of water that allows water to climb up into the roots of plants. And then we talked about solvency. Solvency being how well does water dissolve other substances and why. And we discovered that the polar qualities of water actually pull other polar substances apart, pull the molecules apart, and brings them into solution. And now we're looking at the heat capacity of water. Still, another property of water allows it to absorb heat without showing large changes in temperature. This property is called specific heat. And more accurately, we would say specific heat capacity. Specific heat capacity being that property which allows water to gain energy, to warm up and to heat up slowly without showing large changes of temperature on a daily basis over time, which means it warms up slowly. It gains a lot of heat, it has a high capacity for heat, but it warms up slowly, and it also cools slowly. So, because of its high specific heat, large bodies of water moderate or control the climate of surrounding areas by absorbing heat in the summer and releasing it or cooling that heat in the winter. This also happens on a daily basis, heating during the day and cooling at night. So this is what we learned when we investigated sea breezes. Sea breezes blew from the sea to the land, which was cooler at night. Land breezes blew from the land to the sea because the land breeze was cooler at night. This all happened because water gains heat during the day and stores it and releases at night. So the climate near large bodies of water is slightly milder than areas without large bodies of water. Like here in the valley, we have no large bodies of water like Lake Michigan or Lake Erie or the Atlantic Ocean. We have mountains and land masses, but the climate here in the valley and west of the Blue Ridge Mountains is a lot different than the climate near the ocean to the east side of the Blue Ridge Mountains. This property of water, specific heat capacity, also helps living organisms regulate their body temperature more effectively, remembering that our bodies are like 70% plus water, right? And water works and is important in our body to regulate body temperature. Let's look at a couple of sketches that I have to help us understand specific heat capacity. So this sketch shows just what's happening over the course of the seasons with water on the surface of the planet. And this happens in oceans, it could happen in Lake Michigan, Lake Erie, ponds, even rivers and small streams where the sun provides solar radiant energy to be absorbed by the water. So in the summertime, the sun's rays strike directly on the surface of the earth. The water heats up and stores heat, energy. This happens slowly over the course of an entire summer. As the temperatures of the water heat up over the summer, the water gets warmer, a little bit warmer each day, warms up during the day, releases a little bit of heat at night, warms up a little bit more the next day, releases less heat at night, warms up, releases a little heat at night, and gradually it's warming more than it's cooling, and all of the bodies of water on the surface of the planet, as you go towards summertime, get warmer. Then, as we pass summer and head through fall and into the winter, we see large bodies of water beginning to release heat and release thermal energy. The sun's rays are striking at more of an angle rather than directly. We still have solar radiant energy heating during the day and cooling at night, less heating during the day, more cooling at night, and little by little over the course of several months, the bodies of water lose thermal energy, the temperatures go down, and so water releases stored heat energy to the atmosphere. And again, this happens slowly over the course of months. In this sketch, we see, again, the specific heat capacity of water in oceans, lakes, and ponds as they slowly gain and store thermal energy, heat, from the sun during the day, and then slowly release energy as they cool. This would be at night. This describes specific heat capacity. So in the same way that cold water will gain heat from the air, if we take this water jug out of a refrigerator and just set it in the room, it'll gain heat from the air. It won't gain heat from the air all of a sudden. It will slowly come to room temperature. Eventually, this bottle of water will be the same temperature as the temperature in the room. It does not happen in just a moment or two, or even 10 or 15 minutes. It usually will take quite a long time, maybe even as much as an hour, for refrigerated water to gain heat from the air to become room temperature. In this part of the sketch over here, we just see some water, and we see the molecules. And we know that during the day, slow, gradual heat gain of thermal energy occurs in water. But at night, we have the slow, gradual release of heat energy from the water into the atmosphere. Hopefully this helps you to understand specific heat capacity a little bit better. So let's come back with our green marker at this point, and we'll finish up by getting our descriptions marked and the main ideas. This idea of specific heat, there's not a whole lot more to say about this, but we do want to add one idea, and that is that water gains heat slowly, but it also cools slowly. So this whole idea of specific heat is about water's ability to store heat. Okay, what does it mean to moderate? Well, to moderate means to control, to affect something. And in this case, to moderate, what just happens is the water staying the same temperature all the time that it does, say the ocean water, the air temperatures won't change as much, and the climate won't change as much in coastal regions. So that's what this moderate or moderate has to do with. And the only other things we need to do here then, before we finish up, are to mark the main ideas. And so if you get your blue marker, we'll mark the main ideas. So here's the main idea. The specific heat capacity of water allows water to absorb heat without showing large changes in temperature. That means it heats, it warms up slowly, and it cools down slowly. Because of its high specific heat capacity, large bodies of water tend to moderate or to control or to have a little less to have an effect on the surrounding areas by absorbing heat in the summer, storing that heat, and then releasing it through the winter over a long period of time, several months. So the climate near large bodies of water is slightly milder than areas with large bodies of water. The specific heat capacity of water also helps living organisms regulate their body temperatures more effectively. And part of this is because, for example, humans, we're more than 75% water. We're more than 75% water. Our bodies are made up of more than 75% water. And so the way water works, water's ability to gain heat slowly, lose heat slowly, has a big effect on how our body temperature is regulated. So this pretty much wraps up our study of the properties of water, specific heat capacity being the last property that we're taking a look at. And make sure that you have all of your paragraphs marked, you have your margin notes in place, that you have the sketches prepared and onto the back of your pages, and we'll look at the next several paragraphs on phases of water.